Let f of x equal 2 minus 9x plus 6x squared minus x cubed for x is an element of the real number set. So we notice that we have an x cubed value, so we know that our function is going to be cubic, so it's going to be S-shaped. Part 1, find f prime x, the derivative of f of x. Part 2, find the coordinates of the stationary points of f of x, so find the maximum and minimum points. Part 3, use the second derivative test to determine the nature of the stationary points. And Part 4, hence, sketch the graph of f of x in the domain of x values greater or equal to minus 1 and less than or equal to 5. X is an element of the real number set. So Part 1, find the derivative of f of x. Well, we start off with a constant and we can just cancel that out because there's no x value, so we can't differentiate a constant. Then we have minus x, and we're just going to cancel out the x, so the derivative of minus 9x is going to be minus 9. Then 6x squared, we bring down the 2 in front. 2 by 6 is 12, reduce the power by 1, 12. 2 minus 1 is 1. And then minus x cubed, we're going to bring down the 3 in front and reduce the power by 1. So we end up with minus 3x squared. So the derivative is going to be minus 9 plus 12x minus 3x squared. Part 2, find the coordinates of the stationary points of f of x. So find the coordinates of the stationary points of our function 2 minus 9x plus 6x squared minus x cubed. So stationary points are maximum or minimum points on a graph, and we know that they are the points at which we have a slope of 0. So the derivative is going to equal 0. This is very, very important. So what we're going to do is let the derivative, which we got to be minus 9 plus 12x minus 3x squared equal to 0. And then we're going to solve for x. So what we can do in this case is either use our quadratic formula, known as our minus b formula, or we can divide across by 3, and then we can factorize and solve. If you do decide to use the minus b formula, it's very important that you make this be a positive 3x squared. And if you're changing that sign to a positive, this must change to a minus and this must change to a plus. We can only ever use our quadratic formula with a positive x squared value. So what I'm going to do is I'm going to divide across by 3. So I'm going to start off with the x squared term, and minus 3 divided by 3 is going to be minus 1x squared. But I want to make that into a positive, so it's going to be positive 1x squared. And I'm going to bring it down here in front because we always put our x squared value in front. 12x divided by 3 would give us 4x, but since I changed the sign of my first term, I must change the sign of everything. So 12x divided by 3 would give us 4x, and I'm going to change it to minus 4x. And I'm going to bring that down there because we always have our x term second. Then minus 9 divided by 3 would give us minus 3. And again, I have to change that sign. So I end up with positive 3. And I bring it down here at the end because I always have my constant at the end. Alternatively, I could have divided across by minus 3 and I wouldn't have had to change any signs. So I end up with x squared minus 4x plus 3 is equal to 0. I'm going to factorize and then solve. So factorising this, I get x minus 3, x minus 1 in my brackets. The x squared brings an x down in the front of each bracket. This positive sign tells me that these signs are the same. This negative sign tells me they're both minus. I need to get the factors of 3, which are just going to be 3 and 1. And minus 3 minus 1 gives me minus 4. I can multiply this out to check if I'm right. So I'm going to let x minus 3 equal 0. So x is going to equal to positive 3. And x minus 1 equals 0. So x is equal to positive 1. Now, the question asked me for coordinates. X values on their own are not coordinates. So what we're going to do is we're going to substitute our x values into our equation to find our y values. And it's very important that we sub them into the original function. Very, very important. We substitute our x values into the original function. We do not substitute into the derivative. So to find our corresponding y values, let's start off with x is equal to 1. So our function was 2 minus 9x plus 6x squared minus x cubed. So we're swapping the x for a 1 in each term that we have an x. And we get 2 minus 9 by 1 plus 6 times 1 squared minus 1 cubed. And that ends up giving us y equals minus 2. Then we sub in the x value again into the original function. Very important, it goes into the original function, not the derivative. So we get y equals 2 minus 9 times 3 plus 6 times 3 squared minus 3 cubed, which end up giving us y equals 2. So our stationary points are going to be 1 minus 2, an x value of 1, a y value of minus 2, and also 3, 2, an x value of 3, a y value of 2. So these are our stationary points on our graph. Okay, part 3, use the second derivative test to determine the nature of the stationary points. So the first thing we have to do is find the second derivative. So our derivative was minus 9 plus 12x minus 3x squared. So our second derivative, we are going to cancel out the minus 9 because it's a constant, it cannot be differentiated. For plus 12x, to differentiate that, we just cancel out the x, so we get 12. And then for minus 3x squared, we bring down the 2 in front. Minus 3 by 2 is minus 6, and 2 take away 1 is 1. So we end up getting 12 minus 6x for the second derivative. Now, we got x values of 1 and 3 in our previous step. So what we want to do is substitute 1 and 3 into the second derivative, so into 12 minus 6x. So if I sub in 1, I'm going to get 12 minus 6 multiplied by 1, and that's going to give me 12 minus 6, and 12 minus 6 is 6, which is greater than 0. Therefore, at x is equal to 1, there's going to be a local minimum. So, if we sub in 1 into the second derivative, we get 12 minus 6 multiplied by 1, which gives us 12 minus 6, which gives us 6. And 6 is greater than 0, so at x is equal to 1, there's a local minimum. Because if we get the second derivative greater than 0, we have a local minimum value. And likewise, if we end up getting the second derivative to be less than 0, we'd have a local maximum. So the other x value that we found was 3. So we're going to sub in 3 to our second derivative. So we're going to have 12 minus 6 multiplied by 3, which will give us 12 minus 18, which will give us minus 6, which is less than 0. So at x is equal to 3, so when we subbed in 3 to our second derivative, we got minus 6, which is less than 0. So at x is equal to 3, there's going to be a local maximum. So again, we wanted to substitute 3 into the second derivative. So 12 minus 6x, we end up getting 12 minus 6 multiplied by 3. And minus 6 by 3 is minus 18. So it would be 12 minus 18, which gives us minus 6. So subbing in 3 to the second derivative gives us minus 6, which is less than 0. Therefore, at x is equal to 3, there's going to be a local maximum. So if we get the second derivative to be greater than 0, it tells us at that point we have a local minimum. So second derivative greater than 0, we have a local minimum at that point. If we get the second derivative to be less than 0, then at that point we have a local maximum. So second derivative less than 0, we get a local maximum. So to summarize, the coordinates of the local minimum are going to be 1 minus 2, because we subbed in an x value of 1 to our second derivative, and we got our answer to be 6, which is greater than 0, so we have a local minimum at the point of 1 minus 2. And the coordinates of the local maximum are going to be 3, 2. Because we subbed in 3 to our second derivative, we got minus 6, which is less than 0, giving us a local maximum. So the coordinates of our local maximum are 3, 2. Be careful, because we were asked to find the stationary points, which means we have to have a coordinate, so an x value and a y value for both of them. So just be careful that you don't just end up saying it's going to be local minimum or local maximum. You have to explain at the end what the actual coordinates are. In this case, 1 minus 2 and 3, 2. Hence, sketch the graph of f of x, which is 2 minus 9x plus 6x squared minus x cubed, in the domain x values greater or equal to minus 1 and less than or equal to 5, and x is an element of the real number set. So our function is 2 minus 9x plus 6x squared minus x cubed, and we want to sketch our graph for x values greater or equal to minus 1, less than or equal to 5. So what we're going to have to do, first of all, is find the coordinate when we sub in an x value of minus 1 and an x value of 5. So we're going to find f of minus 1 and f of 5. So subbing in minus 1 to our original function, we get 2 minus 9 multiplied by minus 1 plus 6 multiplied by minus 1 squared minus minus 1 cubed. That gives us 2 plus 9 plus 6 plus 1, which gives us 18. So our x value would be minus 1 and our y value would be 18. We also sub in the x value of 5, so we'll into the original function. So we'll have 2 minus 9 times 5 plus 6 times 5 squared minus 5 cubed, giving us 2 minus 45 plus 150 minus 125, giving us minus 18. So f of 5 is going to be minus 18. We also should substitute in 0. So f of 0 would end up giving us 2 minus 9 times 0, which would cancel out, plus 6 times 0 squared, which would cancel out, minus 0 cubed, which would cancel out. So really you're just going to be left with 2. You can just cancel out any x values. So f of 0 is 2. So using these points and the stationary points, we can sketch our curve. So we subbed in minus 1 as our x value and got 18. So one coordinate is going to be minus 1, 18. We subbed in 5 and got minus 18. So one coordinate will be 5 minus 18. And we subbed in 0 and got 2. So our other point will be 0, 2. So again, these are the 3 points that we have just worked out. So we subbed in minus 1 into our original function, and we got an answer of 18, so our y value was 18. So that's what happened there. Then we subbed in 5 to our original function and got an answer of minus 18. So our x value is 5, our y value is minus 18. That's what happened there. And we also subbed in 0 and got out 2. So our x value is 0, our y value is 2. So that came from there. So in general, whatever domain that they ask you to sketch your graph in, you're going to substitute in the lower x value and get out a y value. In this case was minus 1 and we got out 18 for our y value. You're going to substitute in the largest x value, in this case 5, and we got out 18, minus 18. And then you should also sub in 0 to see what your y value will be. So you're going to need 3 points. And also the stationary points to sketch the curve. So the points that we found were minus 1, 18. So I'm going to go to minus 1 on my x-axis and 18 on my y-axis and plot that point there. So that's a point minus 1, 18. I also had 5 minus 18. So I go to 5 on my x-axis, minus 18 on my y-axis, and join them up to get that point there. So it's a point 5 minus 18. I also have the point 0, 2. So I go to 0 on my x-axis and 2 on my y-axis. So that's that point there. And then I also have my maximum and minimum points, my stationary points. So I've got 1 minus 2, so I go to 1 on my x-axis, minus 2 on my y-axis. So that's going to be my minimum point. And I also had 3, 2, so I go to 3 on my x-axis, 2 on my y-axis, and plot that point. That's my maximum point. And then I can join them together in a curve. And there I have the graph of 2 minus 9x plus 6x squared minus x cubed.